Hi, welcome to the Air Manager API tutorial video series. In this video we're going to be talking about Canvas. So last time we spoke about Canvas, we spoke about initially setting up a canvas and filling the canvas with some basic shapes. So we're going to look at a few more of those draw callback functions that give some of these more complex shapes and arcs and whatnot in this video today, and then maybe we'll do one more just showing how you can combine some of these functions to produce a few basic functions that we may want to use in an instrument. So let's jump straight into our code then. So if you remember last time, we set up our draw callback and a redraw callback after we specified our canvas. We rotated it a little bit, and just to show how the canvas rotates, and then we showed how you overwrite the canvas, or you redraw the canvas using either the different function or the same function. If you were to change some of these parameters, then maybe the images could move. So what I've got set up here now, and what we did last time, is we set up another redraw at the very end of the code here, calling up function redraw2, but it's another canvas draw function. So the redraw2 was just populating our canvas with a few of the basic shapes. So we started with a line. I explained about the stroke and the fill, and then we looked at rectangle, triangle, circle, and an ellipse. So if we go ahead and run our instrument, which is how we left it last time, you'll see we've still got those shapes from the last video. We put our line and a couple of triangles and our rectangles and our circles and our two ellipses. So each of these showing sort of like the fill or the stroke version of that particular function. So now we're going to start looking at arcTo, quadratic, and Bezier 2. So really, essentially, you'll get an idea for the flavour of what you can do with these functions as we go through each one. But essentially, these are drawing some arcs, and they're slightly different in the way that they operate. And then the quad and the Bezier line will give us an option to see quite a lot of parameters there to adjust the control points for that Bezier line to make it look however we want. So, as I say, these are probably more advanced functions. You may want to use them for things like drawing course lines or waypoint, not waypoints, but a flight plan, or I suppose any other object that you might want these complex shapes in. So let's delve straight in then into the first one, which is arcTo. So let me just uncomment this quickly, and then go back to the let's just save that. We'll go back to the API page. So if we go to arcTo, you can see here for the arcTo function, it's got these 5 parameters. So a CPX stands for the control point X, control point Y. So there's a control point that you set up, and then the X and Y is the exit point of the arc that we're going to draw, and then the last parameter is the radius. So there are 5 parameters, or our 5 arguments, and you can see here we start by doing a move to. So I explained move to last time, saying that basically it was setting your start of your drawing point on your canvas as similar to a cursor position. So you set your drawing point up to be, in this case, 10 pixels in from the left of the canvas and 80 pixels down. So 10 pixels in is going to be sort of roughly level with that, and then 80 down is going to be around about here. So we're going to start drawing from around about this point. And then the arcTo function, these two are the control points. So if we go back to the wiki example, and we can click arcTo, I think this one's got a little, yes it has. Okay, so when we're talking about the control point, we're essentially talking about this point here, okay? And then the other x and y is the end of the arc. So the x and y position, as it explains here, this is the left pixel and the top pixel for the x and the y of where the canvas where the end of the line should be. So yeah, so where the end of the arc finishes, that is the x and y position where you want it to be, and then the control point is this bit here. So this is where you've got your arc in the very corner here. So we'll go back to the function here. So you can see now we've got a control point of 70 pixels by 80, so it's the same height as where we're the same distance down from the top that we're starting our draw from. So it should just give us a line along here, but we're going from 70, so we're starting at 10 there, but we're not going to start drawing our arc until 70, so that's going to be sort of here somewhere. And then, sorry, that's the silly me, that's the control point. So the control point is over here, so it's 70 across, 80 down, so that's around about here. But the actual arc itself is going to start at this move to point, and then it's going to draw to, which is the final x and y, if you remember from the wiki that we just looked at. That is going to be 70, so it's going to be the same as the control point, so it's going to be 70 in, so it's going to be sort of down there, and it's 140, so it's going to be much further down, so it's going to be around here. So you can see, similar to that shape that we saw on the wiki page there, we're going to get an arc starting from here and coming round to here, because this is where our control point is, up here. Which is denoted by these first two arguments here. And then we're going to draw a radius of 60. Now you can see these have been carefully chosen, these values, so that these all kind of tally up in terms of what they're asking for. If you start making silly numbers in some of these arguments here, like you make the radius not work with the exit point or the control point, then you're not going to get the result that you expect. So you can see that that's got a radius of 60 because we're starting at 10 and we're going to 70. So those numbers stack up right. If we make this something different to that, we'll get some weird results, and I'll show you what they're going to look like in a minute. And then the next one is almost exactly the same. It draws the same, well, the same arc in the same proportions, but it just shifted to the right here a little bit, similar to the way these are laid out. So on the first one, we're going to do a fill of just a random collection of hex values there. I think that's a sort of greeny colour. And then we're going to just do a stroke with a thickness of 2 in all zeros, which is black. So we're going to get a filled arcTo, and then we're going to get a stroke arcTo. So let's run the instrument and you can see what I'm talking about. So there you go. In the first example, it's drawn that arc, so the control point, remember, is around about here where I'm pointing to with the mouse cursor, and you can see that you've got an arc to these x and y here of 70 and 140 and a radius of 60. And because you're asking it to fill, what it's doing is going from the first point to the last point, and it's just drawing a straight line between those 2 points, and it's filling everything else between that arc. So obviously if you don't want the fill, you use the non-filled version, but you'll see how the fill acts with the next one, the arc, which is a little bit different. You can do it a different way in terms of which way round it fills. I'll explain that when we get on to the next one. So that's arcTo. So that may be handy for, you know, if you had a flight plan line where you're drawing a straight line coming into a certain point, and then you wanted an arc to exit at a certain point of a certain radius, and then you wanted to carry on drawing a straight line again, you could use a combination of the move to, line to, and the arc to get that line. So the next one then is arc. So arc, you can see here in our example, we have CX, CY, start angle, end angle, radius, and then this extra one on the end called direction. So let's just go back to the wiki page and have a look at arc. There we go. So the description for the arguments here then is CX and CY. This is the left pixel of the control point. Okay, and then CY is obviously the top pixel of the control point. So CX and CY are the control point definition. The start angle in degrees, and this is important here, 0 is at the 3 o'clock position, so not perhaps where you may think at the 12 o'clock position. 0 is over here, 0 degrees. So that's where, if you don't want to start drawing from there, you have to reference from that 0 position and say where you want to start things. So you can see in this example here, they're starting at 90 because that's 0, so 90 is around here, and then they're drawing to 180, which is obviously complete opposite zeros, which is down here, so 90 to 180. So you have to remember that 3 o'clock position as being 0. Then obviously the end angle is the second of those two arguments there, the 180 there, and then the radius, fairly self-explanatory, is the size of the arc, the radius, and the direction comes into play when you're doing the fill in terms of which way it will fill on the outside or the inside. I'll show you what I mean by that when we run this code. So let's go ahead and run this, and you could see with these numbers that we've got in here what we've got. Okay, so now what we've got here then is we're saying that the control point is 180 by 110, so 180 in by 110 down, so that essentially is the center here now. So it's not like a line to where you're coming in from a certain point and you're following it round like the circumference of a circle. This is the central point now we're talking about now in terms of this control point. And then we're saying that we want to start at an angle of 0, so we are starting at that 3 o'clock position. Yeah, you can see us starting at the 3 o'clock position. You can see we're using the same angles on both of these examples here. So you see that one has started from 0, that one has started from 0. Now, and then we're going to an angle of 120 degrees. So you can see that 90 would be straight down here. A little bit past that is 120. Same with this one. 90 would be down here somewhere. That's 0. So 90. So 120 is around there. So we're getting the 0 to 120, 0 to 120. But you can see they look quite a bit different. They're obviously the two sort of segments of a circle there. And the difference being that one is a true and one is a false in terms of the direction. So you can see on the first example where we've got fill, where we're using the fill, which is this grey colour, we've said true. So true is saying that I want you to go in the true direction from 0 to 120, around there like that, and then obviously it does similar to what the arcTo function does. It draws or it fills an imaginary straight line between those 2 points and then fills in between it. If I say false, then it would go in the opposite direction, which is why on this next example where we're using stroke, false will go in the opposite direction. Now if we were to change, say, that first one to false, then what will happen now is it will draw the other way around, and then because it's going to fill the line in, we should see this bit grey and this bit not, or at least that's the theory anyway. So there you go. Now this bit is filled in grey because it's drawing in the false direction. So not the clockwise, if you like, is true, and anti-clockwise would be false. So all the way from 0 is still, the two reference points are still the same. It's still 0 and 120, but you're just not going in this direction. You're going in that direction when you start. So to get to 120, you have to go all the way round there, and then it draws the imaginary line and it fills what's inside. So you can use the true or the false to fill either way, or to give you the arc, either a small little arc here or a big arc there, or if you wanted 0 to 180, you could have an arc going there, or you could have an arc coming down the bottom half, depending if you had it set to true or false. So fairly straightforward, that one. A little bit easier than the arcTo to get your head round. Okay, quadratic. So let's go back and look at quad. You can see this has only got 4 arguments here, but this gives you an example of what we talk about when it's referred to a quad. So you can see now this is the definition of the control point again, and then the x and y. So probably similar to the arcTo in that respect, that you set up an initial move to get your called it pen here, or like your start of your drawing point, and then you tell it a control point, and you give it the x and y end of the line point, but obviously you're not giving it a radius here. So essentially, if you think of that as the quad curve, and then if you pull that control point out further and further, then obviously or you pull it over here, you're going to affect where the curvature of this line is. So you can get all kinds of weird shapes with a quad, as you can see here. So let's go back and see what the numbers that we've got look like. There you go. So we've drawn again the same thing here. This is an example of a sort of the top half of a circle, but it's sort of just stretched up a little bit, just so you can see that. So we have 320 by 80 is our control point. So 80 is sort of around about here, I think, from memory on these other ones. 320 is probably around about here, and then 350 by 140, so that's our exit point, so that's over here. So we actually start 290 by 140. So you see 140 is all the way down there. There's your 290, so that's your starting point. That's your which is set by your move to, so that's where you start with your pen, as it was called on the wiki example, and then your control point are these two, and that is your exit x and y. So the end of the curve is your x and y, the last two there, and then your control point, you can manipulate that. So let's just play with that a little bit. So let's shift our control point over to the right a little bit in x, and just see what happens to that. I'm sorry, we're talking about the fill one there. You can see it's stretched that control point now over to the right, and obviously if we with the other one, if we what did we set that to? 350. Let's see if we can drag that one the other way. So that one dragged that way. This one should obviously correct now, and this one will probably come back this way somewhat. There you go. So you can see how you can pull that control point around, and you can play around with where that and you can go very silly with that. Not silly, but in terms of the shape that you're going to get now. I've increased the Y by quite a lot, and oh, it's done some very weird thing there, so maybe that was a bit too much, but you get the idea. Here we go. So let's put that back the way it was, I think. Oh no, what did I do there? Changed the wrong number. There we go. So you can see you can just play around with those numbers a little bit, but essentially the first two are the control point and the last two are the exit point. And then the last one, the Bezier line, again it works similar, but it's you've got two control points this time. So you've got your X and Y as normal here, but we specify control point 1 X and Y, control point 2 X and Y. So again, let's go back on the wiki page. So there you can see you now have two control points to play with. So you can alter the shape by quite a bit more. So you can do these sort of compound curves with control points on the same side of the arc there, or you can flip them around here and do, which is something that we've got in our example. We're just playing around with a shape here where you've pulled a control point right out here, and then another one sort of right down there, and that's applying the math to that line, and you're getting a Bezier line. So they probably have more limited use, these more complex functions. You may find something useful for them. Okay, so what we've got here then is I've just generated a couple of sine waves almost. So again, I've chosen a fill and a stroke, the same parameters on each one in terms of the amount that they've been adjusted for the control points. But you can see here we do a move to, so the move to will start here, and then the end X and Y will finish there. The same with this one, that will start there and it will end there. And then the two control points, one is up here obviously pulling this part of the line up here, and the other one is down here pulling that down here. So in this particular example, because they're nicely evenly spaced, it's kind of created this sine wave looking curve. So you could obviously generate some quite complex curves and shapes if you needed to using these functions. So I think that concludes this video on the more advanced canvas functions. Next time I think we're going to cover the last sort of parts of the canvas, if you like, and that will include using some of these functions together. We've covered all of them individually, but we're going to just probably use one or two of them together, or use some functions of one or two of them just to show you a couple of neat little ideas of how you could start to use them in an instrument. So I think that concludes this video. Please join me again soon for another one. See ya. Bye.